Okay, here we go. Please repeat after me. L'hôpital. L'hôpital. This is not la hospital or any other variant of that, although people want to say that. L'hôpital. L'hôpital's rule. Here we go. So, L apostrophe, H-O with a hat. I don't know, what's the real name for that? I'm not sure they call it.
You've been calling it peahat instead.
Well, yeah, but that's our symbol.
That's the only one I remember. And that's under, isn't it? A carrot.
Okay. Oh, and actually, most times when I write it down, I leave off the hat.
I know what but the hat there means that the letter F used to be an S and they took it out.
Okay, so it used to be a hospital.
Well, that's what it is in French. That means hospital.
Yeah, that means hospital.
The hospital in French.
All right, l'hôpital. How do you pronounce hospital in French? L'hôpital. Okay, how about that? See, I really speak English, so I don't even want to go.
I'll speak that.
You speak straight, or?
No, there's no S.
Yeah.
No, you sing straight.
Oh, I was like,
All right. Let's talk about why we need L'Hôpital's rule. First of all, we use L'Hôpital's rule in this very interesting situation where we have two functions. As functions approach A, they're in the form 0 over 0. Now we know when the numerator gets close to 0, the fraction gets close to 0. But we also know when a denominator gets close to 0, the fraction gets really big. It blows up. Think about 1 over x. When x is 1/2, we got 2. When x is 1/4, we have 4. When x is 1/8, we got 8. When x gets to 1/16, it's getting 6. As we get closer and closer to 0, 1 over x gets really, really big. So what we have is two forces that are seemingly opposed to each other. One says, start getting smaller. The other one says, start getting larger. These are opposing forces. Who's going to win? Who's going to... One of them's going to end up in the hospital. All right. So 0 over 0, or at least a limit that essentially evaluates to 0 over 0, is essentially meaningless and indeterminate because we don't know who's going to win. L'Hôpital's rule allows us to evaluate limits that are in this form. It allows us to choose who's going to win. I mean, I shave, but it doesn't make a difference. I'm like, yes. I got like a Homer Simpson beard. This comes right back down. Are we done with this slide?
no.
Okay. I'll take this. This goes over here. All right. Are we ready to go on now? Okay. So we first described where is it that we're going to use L'Hôpital's rule. The second thing we have to do is what is L'Hôpital's rule? What is this procedure that's going to allow us to choose winners versus losers in this battle of 0 versus 0? Here's L'Hôpital's rule. It says that if we see a function, if we see a limit as x approaches a, in the form of f of x over g of x, and if g of x is going to 0, and f of x is going to 0 as we approach a, and if f prime and g prime both exist at a, then what we can do is we can simply take the derivative of f of a and g of a and find out there. In other words, two things are going to 0. We're looking at the relative rates at which they get closer to 0.
Rates?
Rates. Well, isn't f prime a rate? Isn't it the rate rate of change in the function f? Isn't g prime the rate of change in function g? The derivative? How much does g change with respect to x? Yeah, we're going to look at the rate at which they get closer to 0. And the one that gets closer to 0 faster wins. It's like a game of going bankrupt. Two people are going to go bankrupt at the same time, but who can go bankrupt first? Well, they're approaching 0. Their funds are approaching 0. So who gets to go bankrupt first is the person to lose their money, the rate at which they get go bankrupt. Okay. Can I show you an example? My favorite example of L'Hopital's rule. Here we go. It may be very well be on the next slide. It's probably, Trevor, you're probably right. All right. Let's look at the next slide. No, it's an image. Okay. Here's the justification of L'Hopital's rule. All right. The blue line is our function f of x. I believe the color would be cyan line. Yeah, cyan. I'm sorry. How embarrassing. The blue line is actually cyan. The pink line is actually magenta.
The red line.
The red line's right.
Wasn't there a blue case named magenta?
Yes. Yes, it's a dog. It has glasses.
And magenta's a boy and blue is a girl.
No, they're both girls.
They're both.
They're both girls. No, magenta is a girl. Blue is a girl. Blue is a girl. Magenta. Believe me, I'm much closer to this than you are. What? That's Dora. That's something else.
The guy in the green shirt was.
Oh, Steve. He was not a drug addict.
Totally.
He's not a drug addict.
So was Barney.
All right.
Probably.
I'll show you the website that Steve's website.
Thank you all for going on the recording.
All right, come on. Back up to here. Okay, so here's the analogies going on. F of x is this cyan line, and as we get closer to A, it goes to 0. Okay? G of x is the magenta line, and it's also getting closer and closer to 0. Now, think about this idea of rise over run. I'm not at A yet. I'm at some arbitrary x value away from A. What's going on here? I've got this distance here is f of x. This distance here is g of x. And now what I can do is I can put those things together and say, all right, one way of looking at this fraction, f of x over g of x, is to think of them as the two slopes. F of x over x minus a divided by g of x divided by x minus a. Those are those two slopes. The slope of f and the slope of g. And this ratio is the same as f of x over g of x. Now, what happens as we get closer and closer to A? Those slopes are no longer straight line slopes. As the gap between A and x get closer and closer, what we really end up getting is not m1 over m2, but f prime at A divided by g prime at A. We know the whole definition of the derivative is what happens when the denominator gets closer and closer to 0, as h approaches 0 from their definition of derivative. And so the limit as x approaches A of m1 over m2, slope of 1 over slope of 2, ends up being exactly f prime of A divided by g prime of A. So symbolically we can show that L'Hopital's rule makes sense. I really still prefer the idea of who gets to 0 fastest. Who's going to win that race? And once we know that they're both going to 0, The question is, at what rate do they get to 0? And now I think, Trevor, we're ready for my favorite application of L'Hopital's rule. Almost? All right. So Steve left Blue's Clues, not because he was a drug addict, but rather because he was becoming bald. For real. And it's like, I'm in this cartoon show, and I'm playing with imaginary friends, and I'm becoming an older man, and I've got baldness, and I'm like, how am I going to deal with this?
Because he was addicted to meth.
No.
Why couldn't we do something about that? Like,
Yeah, he did. He wore a toque for the last 2 years that he shot the show. Just like David Letterman.
why is it bad that he's bald?
Because you can't continually play this essentially kid's character forever.
Mr. Rogers did it.
But Mr. Rogers didn't pretend to be, you know, he embraced. But Steve's character couldn't do that. So that's why they shipped him off to college, and that's why his brother Joe.
There's no way they can survive.
You thought his name was Orange?
But how old was he?
He was in his late 20s when he left the show.
The name of the guy who replaced him?
Well, the character's name was Joe. The actor's name was Donovan, as compared to Steve, which was played by Steve. Stephen Burns played Steve.
Well, they couldn't call the guy Donovan.
I'm a father of a 6-year-old and an 8-year-old. Do you know how many episodes of Blue's Clues I had to endure?
Still, how do you know, like, the actor's name?
Oh my God.
Okay, here we go. So, here we go. We're going to go and finally, let's get back to calculus. Here's the situation. I'm taking a limit. The limit looks to be in the form of a function over a function. When I try to apply the limit, what do I get on the top? When I try to apply the limit, I put a 0 here, and I get square root of 1 minus 1. The whole top acts like a 0. What happens when I apply the limit to the bottom? Another 0. We say that form is indeterminate. So here is the exact notation I need you to use when applying L'Hopital's rule. I put an equal sign. I keep the limit. I say that the limit is still approaching 0. And now I'm going to take the derivative of the top, and I'm going to take the derivative of the bottom. I am not going to use the quotient rule. Derivative of the top divided by derivative of the bottom is the application of L'Hopital's rule. So the bottom is easy. The bottom, the derivative is 1. Let's remember what the derivative of the top is going to be. Keep the inside the same. The exponent on that expression is 1/2, so that 1/2 goes out there. Reduce the exponent by 1. Do I have a chain rule?
Times 1.
Times 1, I won't even write it. All right, so now, at this point, I'm going to clean that up. I'm going to clean this expression up. I get the limit as x approaches 0 of 1 over 2 times the square root of 1 plus x. I took that negative 1/2, forced that down into the bottom of the fraction. I took the 1/2 that used to be in the numerator, forced that 2 down in the bottom of the fraction, and now I ask the question again, hey, what is the limit as x approaches 0 of this new expression? Edmund is absolutely right. It's 1/2. That's a substitution kind of limit, right? I throw the 0 in there. It doesn't blow up. I don't get a denominator equal to 0 kind of thing. It's a straight substitution 1/2. Okay. We have just found a new kind of limit. And that's perfect notation. And then what I expect from you? Perfect notation. Any questions about this example?
Why is that the half?
When Edmund took this 0
Yeah.
and plugged it in for x, you got the square root of 0 plus 1. Oh, sorry, 1 plus 0. That's the square root of 1. So I got 1 times 2 times the square root of 1, which is 1. I just got 1 over 2 times 1. 1/2. One more time.
I got it.
because I can plug in that 0 and this denominator didn't blow up. So yes, Ken? Well, when I took the derivative of that numerator, it's looking at the rate at which it was changing. Something like someone's going to become bankrupt. How quickly are they spending their money? This numerator is the derivative of that numerator. This denominator is the derivative. That's the rate. And when I think of the race, it's the rate at which things are changing. Okay. Part 2 of L'Hopital's rule. The first L'Hopital rule I gave you said if you see something in the indeterminate form 0 over 0, this form says, what does it say? What does it say? I don't think it says anything different, does it?
Well, this says x approaches a, so x approaches 0.
Oh, okay.
The other one said as x approaches a as well.
Now hold on. Stop this 1 second.
Wait, was it?
This one's talking about the derivative existing at a, and this one is saying that f and g are differentiable on an interval that contains a. So we're talking about the outside containing. I don't see much difference. Let's go on.
Because in fact the derivative doesn't have to be differentiable anyways.
Okay. Yeah. It's yours. Yep. Seems that way to me. Okay, let's take a look at this new limit. Okay. First step. What happens if I do substitution on this limit? Well, the bottom blows up, right? But what about the top? It becomes negative 1? Okay, the square root part turns into a 1. Minus 1. So both of those end up canceling out, and that leaves me negative x over 2, which turns into a 0. Hey, this looks like it's another one that's indeterminate in the form of 0 over 0. So what do I want to do? I declare L'Hopital in effect. And none of these have been my favorite problem yet.
You're worried it was the last one.
What?
You're worried it was the last one. It's kind of anticlimactic.
It is. All right, so we see that it's indeterminate in the form of 0 over 0, so we are allowed to take the derivative of the numerator. What do we go approaching 0? Derivative of the numerator, and when I do that, I'm going to get 1/2 1 plus x to the negative 1/2 power. Derivative of negative 1? Minus 1/2. Okay, so derivative of the numerator, and now I have to do the derivative of the denominator, 2x. And let's see, can we clean this up at all? I think I can factor this 1/2 out of both of those numerator terms. I think I can factor this 2 out, and when I do that, I'm going to end up with a 1/4 out in front. And I'm going to get, oops, that's a negative, isn't it, there? I'm going to get what? I think I'm going to leave it up on top.
Why is it negative?
Because the exponent here was to the 1/2. When I took the derivative, I lowered that exponent by 1. So it went from positive 1/2 to a negative 1/2.
Yeah, but why is the...
Yeah, and if you distribute like you
my,
can do
no,
that.
my bad. I was looking at the 1/4.
Oh, because the 2 1/2s create one. When I pull these out, when I pull those 2 out, I got a 1/2. When I
Yeah.
pulled this 2 out, I got another 1/2.
Yeah, I mistook the
Okay.
the equal sign for negative.
Okay, there I got it. All right, now what? I got this big stinking mess that I can't even read, so I'm going to rewrite it in a way that you can read it, which is 0 of 1 plus x to the negative 1/2 minus 1 over x. All right? Pardon me? Do it again. It's exactly right. Explain yourself, Anthony.
Well, if you try to find the limit as x approaches 0, both the numerator and the denominator both equal 0, so you have an indeterminate form.
So we're in indeterminate form again. So indeed, what we're going to do is we're going to do it again. And when I do it again, this is going to be negative 1/2, 1 plus x to the negative 3/2. What about this minus 1 here? What about this? It becomes 1. And now, can I apply the limit? Does it blow up? Wait, isn't this a negative 3/2?
It doesn't matter though, because if you put 1 to the negative 3/2, you still get 1.
Well, I'm just that is true, but when I rewrite this, oh, you're right. That's going to be 1 to the 3/2. So it's going to be a 1 times 2. It looks like this limit becomes 1/8.
Was it x in the 3x or
It was no, that was supposed to be 1 plus x to the 3/2 power. I got cramped up. All right, so there's our beginning lesson for L'Hopital's. Of course, you should finish up your sequence. By the way, we're going to
It would
quiz.
actually be negative 1/8.
Oh, because I lost the negative sign here, didn't I? You're right. Okay, we'll finish up L'Hopital tomorrow. We're going to quiz after 8-2, by the way.
Fantastic.
Something like that. I can recreate it for you.